Welcome to a slow, beginner-friendly lesson on virtual environments in Python, made for absolute beginners. The deep dive begins. Today we go deep on virtual environments. Until now you used UV without thinking much about what happens underneath. In this lesson we slow down and look at what a virtual environment actually is, why isolation matters, and how UV manages dependencies for you. By the end you will read a project folder and know exactly what each part does. Look underneath the tool. Here is what a typical project looks like on disk. You see a folder named .venv, that is the virtual environment, a private Python install for this one project. Next to it sits pyproject.toml, the file that describes your project and its dependencies. uv.lock is the lock file, it records exact versions. Source code lives under src, tests under tests. Hold this picture, a project is a folder with a venv, a manifest, and a lock file. Hold the picture, here is how you create that project from scratch. Run uv init with the project name. uv creates the folder, the pyproject.toml file, and a fresh virtual environment. Change into the folder. Then uv add requests adds the requests library as a runtime dependency. uv add --dev pytest adds pytest as a development dependency, something you need only for testing, not for running the app. uv writes each one into the right section automatically. 2 flags, 2 groups. Once the project exists, you run things with uv run. uv run python-my_project.main runs your main module inside the venv. uv run pytest runs the test suite. You do not activate the venv manually, uv run handles that for you. And when a teammate changes the lock file, you run uv sync to bring your local venv in line. One command, exact same versions, every time. Run and sync. Until now, you have been using uv to manage projects without asking what is underneath. Today we slow down and look inside. Slow down and look. So what is a virtual environment, really? It is a private Python environment that lives inside your project folder. It has its own copy of the Python interpreter, its own installed packages, and its own dependencies. Nothing you install here leaks into other projects, and nothing touches your system Python. Think of it as a sandbox. Inside this one project, you have full control over what is installed, without breaking anything else on your machine. A sandbox per project. Why does isolation matter? Imagine installing every package into your system Python. Project A needs requests version 2.28. Project B needs version 2.31. They cannot both win, there is only one global requests. You would spend your evening upgrading and downgrading, breaking one project to fix another. A venv kills this problem entirely. Each project has its own requests, its own version, its own life. Conflict is the enemy. 2 projects, 2 sets of dependencies, no fighting. That is the gift a venv gives you. Isolation solves it. Let us open a venv and look at what is inside. The .venv folder holds a copy, or a link, to the Python interpreter, plus a folder called site-packages where every dependency is installed. When you run uv add requests, it lands in site-packages inside .venv, nowhere else. Your pyproject.toml declares what you want. uv.lock pins exact versions. The .venv is the result, a real, isolated environment that matches the lock file. Change the lock file, sync, and the venv updates. Where everything lives. Here is the actual layout. Inside .venv there is a bin folder, on Mac and Linux, containing the Python and pip executables for this venv. Under lib, Python 3.12, site-packages, you find every installed library, requests, pytest, erlib3, and so on. When you run uv run python, you are using .venv/bin/python, which only sees packages inside this venv. That is the whole magic, a private Python that knows about nothing else. A private Python. When you know what is inside your project folder, the whole toolchain stops feeling magical and starts feeling understandable. The magic becomes clear. uv init is where every project starts. Pass it a name and it creates the folder, a starter pyproject.toml, a source layout under src, and an empty .venv. Nothing is installed yet, the venv exists but it is empty. The lock file appears after your first uv add, because until you ask for a dependency there is nothing to lock. Run uv init once per project, then never again. Once per project, uv add is how you bring in a dependency. uv resolves the package and everything it depends on, transitive dependencies included, installs them into .venv, and writes the new requirement into pyproject.toml. Notice that one add pulled in 5 packages, requests plus its 4 dependencies. You asked for requests, uv worked out the rest and recorded the exact versions in the lock file. 1 ask, 5 installs. uv sync is the magic command for teamwork. It reads the log file and installs exactly the versions recorded there, not the latest, not whatever happens to be on PI today, but the exact versions your teammate pinned. Clone a project, run UV sync, and your .venv matches theirs byte for byte. No more works on my machine. The log file is the contract, UV sync is how you fulfill it. The contract, fulfilled. A log file is a promise, same versions, every machine, every time. Reproducibility made real. Same versions, everywhere. Let us walk the full workflow once, end to end. You start with UV init, a project is born. You add dependencies with UV add, which updates pyproject.toml and writes uv.lock. You run code with UV run, which uses the venv automatically. When you pull changes from Git, you run UV sync to bring your venv in line with the updated log file. Before you commit, you run UV lock to refresh versions. 5 commands, 1 predictable loop, init, add, run, sync, lock. 1 predictable loop. Here is what the log file looks like inside. For every package, UV records the exact version and where it came from, usually PI. It also lists transitive dependencies. Request depends on erlib3, charset-normalizer, idna, and certify. This is why the log file is long even for small projects. Every package, every version, every source, pinned, so that anyone, anywhere, running UV sync gets the same result. Why it is long. Here is pyproject.toml. The project section holds metadata, name, version, the minimum Python version, and your runtime dependencies. The dependency-groups section holds dev dependencies like pytest, things you need only when developing, not when running. The build-system section tells tools how to package your project into an installable wheel. 1 file, 3 jobs, describe, depend, build. Describe, depend, build. You now have the full picture of what UV does for you. From here, every command has a clear purpose. Every command has a purpose. With UV, you almost never activate the venv manually. UV run does it for you transparently. Every UV run command executes inside .venv. If you ever need to activate it by hand, for example, to use a tool that does not know about UV, you run source.venv/bin/activate on Mac or Linux, or the script's equivalent on Windows. To leave, type deactivate. But day to day, prefer UV run. It is shorter and safer. Prefer UV run. Here is a quick way to prove the venv is real. Run which Python on its own and you get your system Python, probably /user/bin/python. Now run UV run which Python. You get the Python inside your projects.venv. Same command, different interpreter, different packages. This is isolation made visible. UV run swaps the Python you use, transparently, every single time. Isolation made visible. When should you use a venv? The honest answer is, always. Every Python project deserves its own. Never pip install into your system Python, that way lies pain. Commit pyproject.toml and uv.lock to Git, so your teammates can run UV sync. But never commit the .venv folder itself. It is large, machine-specific, and fully reproducible from the log file. Add .venv to your Git, ignore and forget about it. Always, 1 per project. Quick self-check. Can you explain in 1 sentence what a venv is? Can you name the 5 UV commands we used? Can you say which file declares dependencies and which one pins exact versions? Can you point to where the installed packages actually live? If any of these feels shaky, rewind the matching part. You do not need to memorize the log file format, just know it exists and why. Say each out loud. Here is the lesson in 1 breath. A virtual environment isolates one project's dependencies from everything else on your machine. UV manages the venv for you, you almost never touch it by hand. The log file is what makes environments reproducible across machines and across time. And the golden rule, never pip install into system Python. Always use a venv, always commit the log file. Isolate, lock, sync. Next we leave tooling for a moment and talk about testing. Why test at all? What does a test even look like? What is the cost of not testing? After that we go hands-on with pytest, then fixtures and mocking, and finally we package a script as an installable Python distribution. The arc is, isolate your environment, prove your code works, share it with the world. Testing comes next. If you want a quick practice, do this mini lab. Create a project called venv_lab. Add requests. Run a one-liner with UV run python-c to print the requests version. Then open uv.lock and read the first 20 lines. You will see exactly what we covered, a real venv, a real log file, a real isolated environment that you created from scratch in under a minute. Build one now. Thanks for going deep on virtual environments. Next we learn why testing matters. The toolchain is clear.